Example 3 of solving systems of linear equations. We're looking at something about distance, rate, and time. So two hikers start at opposite ends of the Quarry Bay North Point to Stanley Trail in Hong Kong. The trail is 8 miles long and they meet in 2.8 or 2 and 8 tenths hours. If one hiker is twice as fast as the other, find both hiking speeds rounded to the nearest hundredth. Okay, so that's what we're looking for, the speeds or the rate. That's what we don't know. But it says that the trail is 8 miles, so we've got miles, which is distance. We've got hours, which is time. And so rate must be miles per hour. So what are we talking about here? Two hikers, okay. So two hikers. We've got one hiker and the other. So that's a way that we can differentiate them with those words. One hiker, other hiker. And then the two together. Because it says at the beginning they start at opposite ends. So we've got this guy here, we'll call him 1. This guy here, we'll call him other. They're starting at the opposite ends of the trail, and they're both going towards each other, right? They're going to meet somewhere. They're going to meet after 2 and 8 tenths hours. So that is the total time that they've been hiking together, 2 and 8 tenths hours. So would that time be different for one or the other? No, they start at the same time, they meet at the same time, so the time is the same for them no matter what. 2 and 8 tenths, or 2.8. Okay, so what's different, or what else do we have here? The trail is 8 miles long, so that's the total trail, like the whole thing is 8 miles. But we don't know how much distance either one of them hiked. What we do know, what else do we have in here? We've got 8 miles, we've got 2.8 hours. One hiker is twice as fast as the other, so we don't know their rates. Let's say we just use X and Y. But if we use X and Y, then the rate of one hiker is, which means equals, twice as fast as the other. So one hiker's rate is twice the other hiker's rate. So one hiker's going to be going faster. He's going to have more distance, right? He's going to cover more ground because he's going faster in the same amount of time. All right, so I've got an equation here that has to do with that sentence. But I need another equation because I have two variables. So let's finish filling in the table. So rate times time equals distance. X times 2.8 is 2.8x. And y times 2.8 is 2.8y. So 2.8y. And then, so that's this distance, 2.8x, and this distance, 2.8y. And if you take the total, then that's going to give you 8 miles, right? Because it's 8 miles altogether. So that's our second equation. All right. We have our system. We just need to solve this system. We can graph, but that's not really that fun. Looks like I want to use substitution because one of these equations is already solved for one of the variables, x. So let me put that into the other equation for x. So we've got 2.8 times x, which is 2y, plus 2.8y equals 8. Now our second equation only has y in it. I just need to simplify by multiplying 2.8 times 2. And that's 5.6 times y. Everything else is going to stay the same. Now I've got like terms, so let's go ahead and add those together. So that's 8.4 y's altogether equals 8. And finally, multiplication property. I'm just going to multiply the reciprocal of the coefficient of the variable. Same as dividing that from both sides, so that we have y on the left And if we divide 8 by 8.4, that's going to be a decimal. So if I want to round to the nearest hundredth, let's go thousands, 952. And that means I'm going to stay at 0.95. So let me just put that over here next to, what is y? Other hiker. So other hiker's rate would be 0.95 miles per hour. They do want me to find the hiking speed for both, so now I need to find one hiker. Okay, let me take this equation then. X equals 2 times y. We found y to be 0.95, so let's multiply that. And we find that x is 1.9. So 1.9 miles per hour would be the rate of one hiker. Does that seem reasonable? Well, you probably hike faster than that, but there is a way to check to see if we're right? We can just go ahead and put that into our rate times time equals distance. So the rate of one hiker times the time plus the rate of the other hiker, 0.95 times the time, would equal roughly 8 miles exactly total distance, remember? And I say roughly because we did do some rounding. So let's put that in the calculator. The first one gives us 5.32 about, and the second one is roughly 2.66. So if we add those together, that's about 8 miles altogether. So that does make sense. We can state our conclusion that one hiker's speed is 1.9 miles per hour and other hiker is 0.95 miles per hour.